Morning students, in the previous video session we have gone through relative velocity, and today we are going to see very important topic, very important derivation equation of motion. In the second unit you can see already it is taken triangular law of addition. That is one of the very important question, and this is another important very important question in this unit. You know that equation of motion v is equal to u plus at, ac is equal to ut plus half at square, v square is equal to u square plus 2as, and ac is equal to u plus v divided by u plus v into t divided by 2. Like this 4 equation maybe you have learned in your smaller grade. Now we can see how we will solve this by using calculus method. We are using integration differentiation method here, and by using this we are deriving this fourth equation. So that first equation is velocity time relation. Okay, like this 4 relation we will derive. So from this 4 relation we will get a 4 equation. And then first one, we know that acceleration formula A is equal to dv by dt. A is equal to dv by dt. This is the acceleration formula. Acceleration of a body at any instant is given by the first derivative form of the velocity with respect to time. We know this equation A is equal to dv by dt. This is the acceleration formula, and it is the first derivative form of acceleration equation. Second derivative form is d square v by dt square. That day in the formula table I told you to learn that formula table. Now from this equation you can write dv is equal to a into dt. Now what I did means just taken this dt here, cross multiplication. So dv is equal to a into dt. Now integrate equation 1. You can keep this as equation 1. Integrate equation 1. For that while doing the integration we have to give the limit. Here v means we have to give u v. This is the limit. U means initial velocity, v means final velocity. See, so from initial velocity to final velocity we are finding this velocity. So a into dt. Here t is there, so you have to integrate from time 0 to t. That means from initial time to final time. Initial time is 0 and the final time is any time. Maybe 2 seconds, maybe 4 seconds, maybe 5 seconds. So we are integrating this equation. You know that before integration you have to know some formula, basic things. Integration of dv is equal to v. Integration of ds is equal to s. Integration of dx is equal to x. Integration of dt is equal to t. Integration of du is equal to u. So these are the things. Integration of dv means v. Integration of ds means x. Dx means x. Dt means t. Now another type is, this two only we are using in physics mostly. Integration of v dv. V dv means v square by 2. V square by 2. Integration of x dx. Actually this is a formula. X dx means x square by 2. Integration of t dt means t square by 2. Integration of a dA means sorry, integration of s ds means s square by 2. So here you can see two types of integration I have shown you. Integration of ds means what? S. Integration of dv means v. Integration of dx means x. Integration of dt means t. Du means u. This is one type. And this is another type. V dv. X dx. T dt. S ds. Y dy. So what will come? Y square by 2. So this thing you learn. This is a basic thing. So if you know this many things, you can do most of the derivation in physics. Okay. So here dv, integration of dv is what? V. Integration of dv is v, small v. Now applying the limit, how you see? You have to use a square bracket. Here put upper lower limit. This is lower limit. This is upper limit. U, here v equal to a. No need to integrate. Here a is constant. Take it outside. Just integrate this dt. So v u v is equal to a. Integration of dt is what? T. Integration of dt is t. Lower limit, upper limit. Now applying the limit. How we are applying the limit means, instead of this thing we have to apply upper limit minus lower limit. Instead of this v. So what will come? V, upper limit applied, minus lower limit. Lower limit is u. So upper limit minus lower limit equal to a is constant, t. Upper limit is t, lower limit is 0. Upper limit minus lower limit. So v minus u is equal to what? At. Minus 0, no? So that one no need. So you can write this equation. V equal to u plus at. This is equation 2. So we got velocity time relation. Okay, just to take a screenshot of this. It will be helpful for you. Very, very important derivation. The next part is second formula. How to derive displacement. You can write here. So displacement time relation. So this is the second one, displacement time relation. Now you can write the formula. We know that velocity of the body v is equal to ds by dt. So velocity of the body means what? First derivative of displacement with respect to time. That is what? V is equal to ds by dt. From this formula, take this dt here, cross multiplication. So ds is equal to v dt. ds is equal to v dt. Now this you take equation 3. Now substitute equation 2 in equation 3. What is equation 2? Equation 2 is v equal to u plus at. That equation 2 you substitute in terms of this v. So ds is equal to v means from equation 2 v is equal to u plus at. Okay. So ds is equal to u plus at into what? Dt. Now what you can do is ds is equal to multiply this u into dt plus at into dt. Now you see, integrate this. So ds means displacement from 0 to any displacement ds. This is a limit. Lower limit is 0. So displacement is from 0 to upper limit, any displacement. Now u dt, here u is constant, no need to integrate. So dt limit is 0 t plus at into dt. Here only t only integrating, so put again 0 t limit. A is constant. So next step, take the constant outside. U is constant taken outside. So no need to integrate that. Plus here A is constant taking outside. No need to integrate. Okay. T d t. Next step, integrate. ds integration is s. Limit is 0 s equal to u. No need to integrate. dt integration is t. Limit 0 t plus a constant. Here in the format tdt. tdt means what? T square by 2. tdt means t square by 2. Okay. Limit is 0 t. Now apply upper limit minus lower limit. Upper limit is s minus 0 equal to u into upper limit is t minus 0 here plus a into upper limit is t, so t square by 2 minus lower limit is 0. So 0 by 2 is what? 0 only. So s minus 0 s equal to u into t, ut, u minus 0, so minus 0 means 0 only, no need. So plus a into t square by 2, then a into 0 is 0, so leave that. So we got the second equation, s is equal to ut plus, take this 1 by 2 outside, 1 by 2 at square. This is equation 4. Okay, take a screenshot of this and you can study this. If you have any doubt, interactive section, you can ask me. Okay, take a screenshot of this, practice this. It is very important. You have to write this in your notebook. Okay, this is what a displacement time relation. Then the third one is velocity displacement relation. Okay, so here we are taking acceleration formula again. A is equal to dv by dt, first derivative form of acceleration. Now already here 4 equation came, so take this as 5. So what you have to do means, here multiply and divide by ds in equation 5. That means you have to multiply and divide by ds in this equation 5. So a is equal to dv by dt into ds by dc, multiplied by ds divided by ds. Now I am taking this ds here and dt here. So a is equal to dv by this ds I am taking here. So ds into ds by this dt I am taking this side. So dt. Now we know that this ds by dt means what? ds by dt means displacement by time, that is equal to velocity. Now multiply here. So a is equal to dv by ds into v. Now take this ds this side, cross multiplication. So a ds equal to you can write v dv. Instead of dv into v, you can write what? V dv. That is our integration format. Now integrate this equation. You can put 6. So integrate equation 6. Now a ds. Here a is constant, no need to integrate, only ds is integrating. So 0 to s equal to v dv. Here 0 to, not 0, velocity. So initial velocity is u, final velocity is v. Now here a is constant, take it outside. Only ds is integrating. 0 to s u v dv. So a into ds integration is s. So limit 0 to s v dv. V dv, what format of v dv means? V dv means v square, ds means s. So v dv means v square by 2. Limit, upper limit lower limit u, upper limit v. So this much only integration, very simple only. In physics we are using simple integration method. Now a into apply upper limit s minus 0 equal to, here upper limit is v, so v square by 2 minus lower limit u square by 2. Okay. Now here what will come? As equal to, here 1 by 2 is commonly taken outside. So inside the bracket v square minus u square by you will get. Now take this 2 here, cross multiplication. Take this 2 here. So 2as is equal to v square minus u square. Now take this on this side, 2as another side. So v square minus u square is equal to 2as. Now we need v square is equal to, take this minus u square this side. So plus u square. So u square plus 2as. This is equation 7. Now we got a third equation. Now we got 3 equation. V is equal to u plus at, s is equal to ut plus half at square. And the last equation we got is v square is equal to u square plus 2as. Now for the fourth equation, we are taking equation 1. So from equation 1 means v is equal to u plus at. Now from this equation, what I am doing means this u I am taking this side. So v minus u is equal to at I am taking. So at is equal to v minus u. Okay. Already here 7 equation came. This is equation 8. Now we are taking another equation. This equation 4, s is equal to ut plus half at square. So s is equal to ut plus half at square. So from this equation, what I am doing means S is equal to ut plus half a t into t. T into t is t square. I am splitting and writing. So I got here at. This is equation 9 you take. Now instead of this at, you have to substitute v minus u. So substitute equation 8 in equation 9. So what we will get? S is equal to ut plus half. Instead of at, you have to substitute v minus u into t. So S is equal to, now this 2 is common here. So take here LCM. So 2ut plus v minus u into t by 2. So I have taken LCM 2 commonly. So here 2 came. Next step, S is equal to 2et plus v into t, vt minus u into t, ut by 2. Removing the bracket, I am multiplying with the t. So S is equal to 2ut minus ut. So 2ut minus ut is what? Here 1 ut is there. So 2 ut minus 1 ut is 1 ut. So 1 ut will come from Vt by 2. So here t is common. So take t outside. So u plus v into t by 2. This is 4 equation. So we got 4 equations. You didn't take a screenshot of this relation, so take a screenshot of this. It will be helpful for you. So all of you write this in your notebook. And the 4th equation, take screenshot of this. Okay. So this is equation 10. Now we got 4 equation. You see, first equation is what? This one, velocity time relation, v is equal to u plus at. Second relation is displacement time relation. So you see, S is equal to ut plus half at square. Third equation is velocity displacement relation. There we got v square is equal to u square plus 2as. Then the last equation is S is equal to u plus v into t divided by 2. This is 1 5-mark question. You have to, in exam they will ask the question. It is question number 3, long answer. Book back question number 3, long answer question number 3. All of you write this in your notebook, practice it. If you have any doubt means you can ask in next interactive session. Thank you all. Practice this. This is one of the very important question in this unit. If you didn't understand any step, you can ask in the interactive section. So as well as you can call me. So my dear students, practice this. Write this derivation in your notebook. And it is in the textbook, page number 76 and 77. Practice this. See you all. Bye bye. Thank you.